Good day everyone. So our lesson is about phase change and also calorimetry. Okay, in this session we are going to look into the different processes in phase change and also what happens during phase change. And then we will also integrate phase change concepts in calorimetry problems. Okay, so stay tuned and try to understand the concepts about phase change.
Okay, so calorimetry again is the process of measuring heat. It's especially used in experimental setup wherein you are using calorimeter and then you combine, let's say, a liquid and then solid material which which were in different temperatures, and then you will analyze or you will solve what will be the final temperature of the system. So that is calorimetry. So this will also be integrated in phase change. Now, when we say phase, of course, is the state of matter, and then there is also a heat involved during phase change. So you can see here in the equation we have Q, or the amount quantity of heat, equals positive or negative. M is the mass, and then L. L is either the latent heat of fusion or the latent heat of vaporization. During the first discussion that we had in heat, we have this what we call sensible heat, wherein that is the amount of heat required to change the temperature of the object. But this time, we will consider the latent heat. Latent heat is the amount or the quantity of heat required to change the phase of an object. Okay? So it's either positive or negative depending on whether the heat is absorbed or released. So there are different processes in phase change absorbing heat, and there are also processes wherein it's releasing heat. Okay? So as we go along with the discussion, you will understand these concepts better. Okay, now I want you to look at the graph. So you have here from negative 20 degrees Celsius to 0 degrees Celsius. So the heat involved there is the sensible heat, wherein the temperature has changed from negative 20 to 0. Okay. So heat is absorbed by the system. But look at what happens to this one at 0 degrees Celsius. So this is where phase change is happening. So if it's from negative 20 to 0, and then here, this is melting, wherein that is a phase change from solid to liquid. So you can see here that the temperature doesn't change during phase change, but the energy absorbed by the system is used to break the bonds, okay? So that from solid, it will become liquid, okay? So that is melting. And then you can see in the next graph, okay, here, in this graph, so this is now in liquid state. So that is from 0 degrees Celsius to 100 degrees Celsius, wherein energy or heat is also absorbed. And then at 100 degrees Celsius, which is the boiling point of water, so we now have here evaporation. So heat is absorbed again, not to change the temperature of the object or of the water, but to change its phase from liquid to gas. And that is evaporation. And then heating it further, so it's still the phase is gas, but the temperature now is from 100 degrees Celsius to 120 degrees Celsius. Okay, again, take note that during phase change, okay, the temperature doesn't change, but the heat is either absorbed or released to break the bonds or also to create bonds. Now let's talk about evaporation. Okay, can you try to answer this first? Now, isipin nyo lang. And then you can also share in the comments. Okay, how is firewalking possible? And then why do you think dogs pant? Okay, so how is firewalking possible? This is done. Yung mga firewalkers, nilulubog muna nila yung paa nila sa liquid so that the heat will not go directly to their feet, but it will be used to evaporate that liquid. That's why they have to walk very fast. Para bago pa ma-evaporate lahat ng liquid layer, so nakatawid na sila dun sa coal. Okay? So that's how firewalking is possible. Now, why do dogs pant? Okay, dogs do not have sweat glands. Okay, we are very lucky we have sweat glands because that is the cooling mechanism of our body. Yun yung natural way natin to cool down. Okay, we produce sweat so that it will evaporate, and evaporation is actually a cooling process. Okay, later on, you will see a graphical representation of evaporation being a cooling process. So I will continue to explain why the dogs pant. They do panting so that through that method, makaka-cool down sila. Because the liquid or their saliva, or yung liquid na nasa tongue nila, panting is the way to evaporate that liquid. Kasi nga wala silang sweat glands. And as I have mentioned, evaporation is a cooling process, so that's how dogs cool themselves down. Okay? So as I have mentioned, I will give you a graphical representation of evaporation being a cooling process. Okay, when we say evaporation, it's a phase change from, ano nga pag evaporation? It's from liquid to gas. So heat is absorbed. Okay? So when we say heat is absorbed, that means it's an endothermic process. So pumapasok yung thermal energy dun sa system. That's why it's okay? Endothermic process. So what happens here? Heat is absorbed. Diba? Ito yung skin layer natin. This is the skin layer. And then let's say this one is the liquid layer or yung sweat natin. Okay, that will actually, the first layer, okay, that layer will absorb the heat from our skin. Because nga, it's an endothermic process, it has to absorb heat so that it will evaporate. So by means of absorbing heat, itong layer na to, which is our skin layer, definitely will cool down. Kasi nga nawala yung thermal energy niya. It was transferred to this layer of water or of sweat. Okay? So that is evaporation being a cooling process. Okay, this also explains this one. Why do pigs love playing in the mud? O kaya bakit madalas pinapaliguan yung baboy? Okay, the same explanation. They also do not have sweat glands. Kaya you have to put some layer of water so that when that layer of water evaporates, magkakaroon ng cooling effect sa skin nila. Okay? So that's why they love to play in the mud or dapat lagi silang nababasa. Okay, next. Another phase change process is condensation. When does this one happen? Condensation happens if it's a phase change from gas to liquid. Okay? So condensation is considered to be a warming process. It is also an exothermic process. When we say exothermic, heat is released by the system to the surroundings. Now, bakit ba pag halimbawa bago umulan, they call it maalinsangan. Bakit bago umulan sobrang maalinsangan? Yung sobrang init. Because what happens is condensation is a phase change from gas to liquid bago umulan. And since an exothermic process, heat is released to the surroundings, kaya sobrang init bago pa umulan. Okay? Okay, now you know that. So tuwing uulan, maaalala nyo ang condensation process, which is a warming process. Alright, so it's time to solve problems on phase change. And then later on, phase change and calorimetry. Okay, so what you see now are different latent heats of different materials. When we say latent heat, that means it's the amount of energy or thermal energy needed for a substance to change its phase. That's why the unit here is joule, which is telling us about the amount of heat per kilogram. So again, it's the amount of heat needed by a unit mass of a substance to change its phase. Okay? Now, this table is the latent heat at 1 atmospheric pressure. And also, we have here the melting point. Kasi it's very important that in the problem solving, you know the melting point of the substances. That, for example, we have oxygen. The heat of fusion there is 0.14 times 10 to the fifth. And then we also have the heat of vaporization is 2.1 times 10 to the fifth. When we say latent heat of vaporization, the phase change involved would be from solid to liquid or from liquid to solid. But when we use the heat of vaporization, so the phase change involved will be from liquid to gas and then from gas to liquid. Okay? So as we solve problems, you will understand these concepts better, whether you are going to use latent heat of fusion or latent heat of vaporization, or whether you are going to use positive or negative. Okay? So let's solve problems. Okay, so now let's solve the first problem. A 0.50 kilogram water is initially at 25 degrees Celsius. How much heat should be released by the water to freeze it at 0 degrees Celsius? Now, if you're still not used to solving for phase change, you can use the graph so that you can analyze how much heat or will be required. What are the different processes which will require heat to be absorbed or released? So for example, in this one, it has started from 25 degrees Celsius. So I'll show you the graph. Okay, I'll show you the graph for this. So you have here. Now it has started from 25. So let's say this one is 25 degrees Celsius. And then there's no phase change at 25 degrees Celsius because as we know, freezing point of water is 0. So what will happen? It has to decrease its temperature first to 0. And then this will be the phase change. Okay? This is where phase change will happen at 0 degrees Celsius. So let's use another color. Okay, from 25 to 0 degrees Celsius is heat absorbed or released. So, sagutan nyo sa isip nyo. Absorbed or released. Okay? Since the temperature will decrease, therefore heat is released. But we don't have to assign positive or negative. It will just be Q from the first discussion that we had, MC delta T. Okay? Wherein the temperature change is from 25 degrees Celsius to 0 degrees Celsius. If you will solve delta T here, that means that 0 minus 25, so it will turn out negative. But for this one, since it's freezing point, you now have to use Q equals, since heat is released, you have to use negative M, which is the mass of the water, and then L, and then F. So LF here is the latent heat of fusion since it's from water to solid ice. So it's freezing, kaya we are using latent heat of fusion. Now, if we are going to express the total heat which has to be released, so that is Q total, I will combine this one, that is M of the water, C of the water, delta T, from 25 to 0, minus MLF. Okay? So that's how we can that's how we can write the equations. Let's analyze this one first and then combine them. So this will be our equation for the total heat released. Okay? Then let's substitute the given. Let's continue. So let's continue solving this one, wherein this was our equation, mass of the water, C of the water, delta T of the water, minus MLF. Let's just be consistent with the units since we are using here 0.5 kilograms. So ano yung mass ng water? That's 0.5 kilograms. Ano yung C ng water is 4,186 joule per kilogram Celsius degree. So let's write it down. Mass of the water is 0.5 kilogram. C of water natin is 4,186 joule per kilogram Celsius degree times delta T again from 25 to 0. So it's final minus initial. Ang final natin ay 0 minus 25. If you interchange that, so your answer will be wrong. So again, it's always final temperature minus initial temperature. So the unit is Celsius degree. Minus, we have here the mass of the water is 0.5 kilogram. So let's not use the calorie per gram because the unit is in kilogram. Ang LF natin, look at the table. So it's 3, looking at the table is 3.34. It's 3.34 times 10 to the 5. Okay. The unit here is joule per kilogram. So looking at the units, or let's answer this one first before we analyze the units. Okay, our answer here is negative 219,325. Okay. Our unit is in joules. Let's analyze the cancellation of units. Okay, so this one is in kilogram. This is in joule per kilogram, Celsius degree. So we can cancel out kilogram. And then we can also cancel out Celsius degree. And then here, since our latent heat of fusion is in joule per kilogram, so we have kilogram, so you have joules. Okay, so our final answer is heat negative. The final answer is that heat is equal to negative 219,325 joules. So negative because heat is released from water to solid ice. Okay, so let's solve the next item. How much energy is required to change a 0.042 kilogram of ice cube from ice at negative 11 degrees Celsius to steam at 110 degrees Celsius? So let's graph it first so that you can understand it better. Where did I get the formulas? Okay, for example, you have here the graph. It has started from negative 11. You have here negative 11 degrees Celsius, and then it will absorb heat until it reaches 0 degrees Celsius. Here, there will be melting. Ayan, so flat ang ating graph. Since the temperature will not change during phase change. And then after that, it will increase up to 100. So that's 100 degrees Celsius, and then there will be boiling or evaporation at that point. So there's no change in temperature again. Then afterwards, it will increase to 110 degrees Celsius. Okay? So now let's write down the equation for each step. And then we'll combine everything. So you have here, during this point, we have M, it's still ice, so that's mass of the ice. C of the ice, take note ha, the specific heat capacity for ice is different from the specific heat capacity for water, and also different from the specific heat capacity for water vapor. So we have Mi, Ci, delta T. Take note also here that the change in temperature is from -11 to 0 lang. It's not from -11 to 110 agad, okay? So, wag nyo madiliin isolve na from -11 to 110, no. So, here, since it's melting, therefore it's absorbing heat, it will become positive. So, ang Q involved here ay positive MLF. It's the latent heat of fusion kasi it's melting. Okay? Then, at this point, since from 0 to 100 naman siya, it's also M. This time, it's already water, MW, C of water, and then delta T. The delta T this time is from 0 to 100. Hindi na siya from -11. And then lastly, hindi pa pala siya last. So we have here positive again since it's absorbing heat. So positive M, but this time it's already LV. Okay, latent heat of vaporization. And then the last one will be from 100 to 110. And that will become mass of the water vapor. So it's already gas. C of the water vapor in gas na. Delta T is from 100 to 110. Okay. So that's how we solve for the total heat that should be absorbed by ice. 1, 2, 3, 4, 5. So let's write down the equation, the whole equation. Okay, so now let's write down the whole equation. We have Q equals mass of the ice, C of the ice, delta T, you have from -11 to 0, and then you have plus MLF, okay, that's mass of the ice, then latent heat of fusion. Then next is plus mass of the water, kasi it has already melted, C of the water, and then delta T. Okay, that delta T is from 0 to 100. And then plus, yun na, meron na tayong evaporation, so that will become mass of the water, and then LV. Then lastly, we have plus mass of the water vapor, so I'll just write G for gas, C of the water vapor, and then delta T, which is from 100 to 110 degrees Celsius. Okay? So that will be the whole equation. So take note that this one is positive because it's absorbing heat, and then this one is also positive since heat is absorbed. So let's substitute the given. We have mass of the ice ay 0.042. Kilogram. I will no longer write the units. You already have understood the cancellation of units, so skip na natin yon. C of ice ay 2,100 joule per kilogram Celsius degree. Final temperature is 0, tapos -11. So that is 0 minus -11. Careful kayo dito ha. Common mistake dyan. 0 minus -11. So this will become positive. Plus, mass of the ice is 0.042. LF ay 3.34 times 10 to the 5. Okay, there. So 1, 2 plus, ito na natin ilagay. The mass of the water is 0.042 kasi it has completely melted, 0.042. C ng water ay 4,186 joule per kilogram Celsius degree. And then, ang delta T niya ay, that is from 0 to 100. So, final temperature natin ay 100 minus 0. Then, this one, plus, mass of the water ay 0.042. Latent heat of vaporization for the water is equivalent to, okay, the latent heat of vaporization is 22.6 times 10 to the 5 there. And then the last one, we have mass is 0.042 again. And then the C for water vapor is 2010 joule per kilogram Celsius degree. And then delta T niya I is from 100 to 110. So final minus initial, that's 110 minus 100. Okay? So there. Pwede nyo naman siya isolve isa-isa. And then you add everything, or you write down the whole equation, then you solve. It's up to you. Solve all together. Sabayan nyo ako mag-solve. Okay, I got the answer equivalent to 128,343.6. Okay, what's the unit? It will be joules. Okay, so that's 128,343.6 joules, or you can also have it as 128 kilojoules. Okay, so let's move on to the next item. This is not found in your module, but let's solve it anyway. How much energy does a refrigerator have to remove from 1.5 kilograms water at 20 degrees Celsius to make ice at negative 12 degrees Celsius? So the latent heat of fusion is 3.34 times 10 to the 5 joule per kilogram. And then the C of ice is 2,100 joule per kilogram Celsius degree. C of water is 4,186 joule per kilogram Celsius degree. So again, let's draw the graph. Pero you are not required to draw the graph if you can already put if you can already complete the equation without using the graph. So, okay, so you have here, let's say we have the graph here. Okay, the problem is how much energy does it have to remove? So from 20 degrees Celsius. So let's say it's 20. Then it will decrease its temperature. And then it will freeze at 0 degrees Celsius. And then it will decrease its temperature up to negative 12. Okay, so there is the graph. Now let's write down the equations. Here we have mass of the water, C of the water, and then delta T from 20 to 0. And now it's very important that you identify the final temperature and the initial temperature. The initial is 20, the final is 0. And then here, since it's freezing, it has to release energy. So that's negative again, negative MLF. And then for this one, it's mass of the ice, C of the ice, delta T, from 0 degrees Celsius to negative 12. So writing down the whole equation, we now have total heat equals mass of the water, C of the water, delta T of the water, from, inote ko lang from 20 to 0. Then you have minus mass of the ice, and then latent heat of fusion. Then we have plus mass of the ice, C of the ice, delta T of the ice, there, from 0 to negative 12. Okay, there. So we can now substitute the given. Okay, let's continue writing the equation. Let's continue substituting the given. You have, oh, okay, we now have mass of the water, 1.5 kilograms. C of the water, 4,186. Delta T, it's from 20 to 0. So, ang final natin ay 0 minus 20. Minus mass of the water is 1.5. Latent heat of fusion is 3.34 times 10 to the 5. Plus, we have mass of the ice, 1.5 again. C of ice is 2,100. And for the delta T, final temperature is negative 12 and initial I 0. Negative 12 minus 0. Okay, try to solve it. Final answer is 664,380. 664,380 joules. Okay, the sign is negative. Okay, since heat is released by the system, so it's an exothermic process. Okay, so let's have the next problem. How much heat is needed to melt 16.5 kilograms of silver that is initially at 20 degrees Celsius? Then the melting point of silver is 960.8 degrees Celsius. The latent heat of fusion is 88.3 times 10 to the 3 joule per kilogram. And then the C for silver is 234 joule per kilogram Celsius degree. Take note that it's not always 0 or 100 nagkakaroon ng phase change. It depends on the material. That's why in your module, you can see there in the table that there are different values for the melting point. It depends on the substance. Okay? So for this one, we have silver, so it's 960.8. The initial temperature is 20 degrees Celsius. So let's graph it. Now it has started from 20. So here is our 20. Then it will move hanggang, let's say, 960.8. Okay, at this point, phase change will occur. Okay, at that point. So there are only two stages for this. We have from 20 to 960.8, we have the mass of the silver, C of the silver, and then delta T from 20 to 960.8. And then here, since it's absorbing energy, so that is positive MLF. Okay, to melt the silver. So we can now have an equation Q, or the total heat absorbed, will become mass of the silver, C of the silver, delta T, from 20 to 960.8 plus mass of the silver and then latent heat of fusion. Okay, so let's just substitute. Ang mass natin ay 16.5 kilograms. C of the silver is 234 joule per kilogram Celsius degree. Take note, dapat temperature is in, delta T is in Celsius degree. Then, delta T is, we have final is 960.8 minus the initial is 20 plus mass of silver is 16.5 and then LF is 88.3 times 10 to the third joule per kilogram. So, our final answer, resolve nyo ulit. Yan, our answer is 5,089,378.8. So, another technique in using your calculator, kapag may exponent, you just use yung EXP. Okay, meron dyan sa inyo EXP or times 10. So, our answer is 5. Okay, final answer natin ay 5,089,378.8. Okay, unit is in joules. Okay. So that is the total heat needed to melt silver. Okay, at 960.8 degrees Celsius.